notebooks. Make sure you're turning to the next clean sheet of paper, pencils out, so that you can write down the first problem. We're going to keep working on probability. This is more or less our last day on simple probability. Tomorrow is your assessment, which is going to be your project. And while I wait for everyone to make sure that they're joining, go ahead and start your matching. You have 3 matches. It's all probability based off of a 6-sided number cube. So you're basing your answers off of a 6-sided number cube. Remember, if you need to write down all the numbers on a number cube, you can. Okay, let's go ahead and look at your first question. So this first question is the one you're going to write down question and answer choices in your notebook. Question and answer choices. Those of you at home, if at some point you can't hear me or you can't see my screen, make sure to let me know. We have been having some tech issues today. You should be able to see it now. Okay, so let's go over real quick the difference between simple and compound probability. So we've looked at maybe one or two compound probability problems, but for the most part, we've been looking at simple probability. And simple probability is a problem where one event is occurring. So you may want to write this down somewhere so that you have it, so you don't forget. Because you're going to have to be able to differentiate between both types of problems. And a compound probability problem is where two or more events are happening. So for example, maybe I'm rolling two number cubes, or I'm rolling one number cube and I'm spinning one spinner. Or maybe even I have to figure out in the menu what's going to be eaten. So I can choose from 5 sodas and 6 sandwiches and 4 desserts. So that would be considered a type of compound probability problem because you have to put all those choices together. Now for compound probability, we looked at it, I believe it was the week before last. We talked about 3 different ways that we can write down how to figure out what our sample space is for that. We talked about lists, we talked about tables, and we talked about tree diagrams. For simple probability, you can really just use a list. Am I good to erase the bottom or another second? We're good? Okay, so this problem says Lillian will roll 2 number cubes, each labeled 1 through 6. What is the likelihood the sum of the 2 numbers showing will equal 12? So it says Lillian will roll 2 number cubes. So what type of problem is this? Simple probability or compound probability? Is it one event or 2 or more? 2 or more, because we're rolling 2 number cubes. So again, anytime that we see roll 2 number cubes or roll 1 number cube and spin a spinner, more than one thing happening, it's compound probability. So she's rolling 2 number cubes. What is the likelihood the sum of the 2 numbers showing will equal 12? So since we're doing compound probability, we need to use a list, a table, or a tree diagram to figure out what the sum of those numbers. So I'm going to go ahead and draw out a table. So because each number cube has how many numbers on it? 6. It has 6 numbers on it. I need to list all of those out. So the top is going to be one of my number cubes, And the side is going to be my second number cube. So what I would do, I need to skip a little space so that I remember to skip that little space. When I do sum, what does that mean? Am I adding, subtracting? What am I doing? I'm adding. So I'm just going to put a little plus here so that I don't forget to skip that space and so that I remember I'm adding. And I'm going to list them out. 1, 2, 3, 4, 5, and 6. Same thing going down. And we worked on something similar last week. The last word on the word problem? Or the last word that I wrote?
Did you see the chart? Because you have to see how many boxes in the chart. So, no, you want to do the sum. You treat this like multiplication table, but instead of multiplying it add. So I added 1 and 1.
Okay, so if you have a different color, you can use it for this. I like to be able to see the difference. If you don't, that is fine. So we're gonna kind of treat it like a multiplication table, but we're doing addition. So I would go down, 1 plus 1 gives me 2. And then I keep going, 1 plus 2 gives me 3. And then I keep going through the whole table. 2 plus 1 gives me 3. 2 plus 2 gives me 4 until I fill in all the little boxes. I wrote this table in 3 diagrams, but it got cut off a little bit on the corner. I don't even get in the habit of saying the first name. Out of how many? Oh, remember. I do that with other numbers too. I just have to if I can't remember my 30. Okay, if you want, you can start the question answer, find the probability or that. Your table down. It's like the one I have there on here. Yeah, so that first row is right. But here is wrong. The 2 plus 1 is what? What's 2 plus 1? 2. What's 2 plus 2? 4. So how many folds are there? How many folds? One out of column. How would you figure out the total? Yeah, then there's no relation. Okay, so we should have it filled in at this point. So if we're looking at our table, how many 12s do we see up there? We see 1 12. So I'm going to go ahead and circle my 12. So that would be, if we're looking at answer over total, that would be my 1 on the top. How many total numbers do I have? So there's 2 ways to figure it out. 1, I count them all. 2, I can take how many numbers are on one cube times how many numbers on my second cube, which would give me what? 36, because it would be 6 times 6. So that gives me 1 over 36. I'm still waiting for your table to be done. So 1 out of 36. Obviously, as I look at my answer choices, 1 out of 36 is not an option, but we need to start with that fraction to help us out. So if it's 1 out of 36, would it be impossible for us to land on 12? No, it's not impossible. It would only be impossible if this was 0. We still have a chance, so it can't be impossible. Could it be certain that I land on 12? No, because in order for it to be certain, this would have to be 36 over 36. All of them would have to be 12. So it's either not likely or likely. Which one am I thinking?
Not likely.
Not likely. So if I look at my chart, 136 would probably land somewhere over here. So it would be unlikely, and you should all have this chart. The only way it would be likely is if this top number was bigger. So if it was something around 25 or something like that, then it would fall into the likely range. So you do have to be careful with that. So let's go ahead and look at the next one. Okay, so for this next one, I'm going to read it the first time. You guys are then going to underline the important information on your computer screen, and you're going to solve. So it says, Sarah has a basket of fruit that contains 10 lemons, 1 pear, 6 oranges, and 3 apples. Sarah will randomly take a piece of fruit. What is the probability of Sarah taking an orange? So for this type of problem, is this simple or compound? So do I need to find matches with my fruit, or am I just picking one out? Simple. So you got to think about those things as you think of your problems, because you will see problems like this that do end up being compound. So go ahead and underline and find your answer.
So now this chlorophyll. And then underline not like the possibility of okay, so when we go to write out our probability, right? We have, answer over total, right? So if we're looking at the probability of taking an orange, how many oranges are there? 6. And how many total fruits are there? Good. So it would be 6 over 20, right? And then we gotta simplify it to find our final answer. Good. There you go. the total, right? So that's the bottom of it, right? So if it's either equal to probability.
This is your own good, your own, input information,
So that would be the
but
top,
you
okay?
didn't.
So that would be that, 6 is your total. Okay, so now we can. Are you gonna start?
So you can divide
So
it
what's the probability
and
of
get
being
to
wrong?
your
So you can add it.
the 6 divided to your whole.
Okay, so then that is simple probability, because that's not one of our answers.
This three, those are our. Yeah. There you go, see? Make sure you understand that information too, okay? Oh, yeah. Good. Oh, it's not. Oh, I see it now, okay. You highlighted it. Good. All you need to do is simplify that fraction. Good. You know what you need to do from here? So, you make a fraction, the top number is going to answer the question. So that is the probability of picking orange. How many oranges could you possibly get? That would be my numerator. So it can sit as if over how many fruits I'm looking at.
So it says Sarah has a basket of fruit that contains 10 lemons, 1 pear, 6 oranges, and 3 apples. Sarah will randomly pick a piece of fruit. What is the probability of picking an orange? So if we answer with our answer over total, what is our answer? How many oranges are there? Go for it.
6.
There are 6 oranges over how many total fruit? 20. And so how did I find that 20? By adding everything together, right? And then you can either simplify manually or you can do it using your calculator. And that gave you what? 3/10. Perfect. So our answer is A. So we're going to look at the next one and you're going to do the same thing. Go ahead and I'm going to read it the first time, then you're going to read it the second time to yourself and underline and find your probability. Hint, there is some information in here that you will not use. So a football team is selling raffle tickets for $5 each. Isaac purchased 10 tickets. The team sold a total of 300 tickets. What is the probability that Isaac will win the raffle? So if it's not important information, again, you don't need to underline it.
Oh, I read it, okay. So I'm assuming that you're not right that, even though that might be.
That was different because I mean,
That makes sense. You want me to do an extra black like in a year. What's not important? Underline it, right? Your answer, no. I don't think you simplified it right. Let me see what you did. Okay, what does that say? So then why did you end up in this is not important, then you don't do anything with it, right? That's the reason you don't underline it, so we don't get confused with something else. You got to, you got it. So like, I saw that you didn't underline, but it's not important, right? So then that means I don't need it at all.
Okay, so it says a football team is selling raffle tickets for $5 each. So is that first sentence important when I am working out this problem?
No.
No, it is not. Because I am not solving for how much these tickets cost. That would be another problem. Maybe once we get into equations. Isaac purchased 10 tickets. The team sold a total of 300 tickets. What is the probability that Isaac will win the raffle? So again, answer over total. How many tickets did Isaac buy? 10 tickets. How many total tickets were in that raffle? 300 tickets in that raffle. If I simplify this, what do I get? 1 over 30th. So if I'm not underlining those $5, remember, then you don't use them. You don't want to end up adding them in there by mistake. Let's look at one more. So this one is like what we were working on yesterday, and we also saw it last week. So for those of you who did not write down the steps yesterday during live, I would recommend that you write these steps down. So a number cube has sides labeled 1 to 6. Sue will roll the cube 48 times. How many times should Sue expect to roll a 5? Okay, so the only difference between this problem and the problems we were just working on is that what is added in there? What else is it telling us? That we're going to do what with that cube? We're going to roll it 48 times. So for our first step, we're going to ignore that piece of information. All we want to start off by doing is find the simple probability. That is our first step. We want to figure out what is the probability of rolling a 5 on a number cube. That's all I want to do first. If you have to cover up that 48, if you have to draw a line through it and then erase it for your second step, that's fine. Or list out your steps, whatever you have to do so that you don't get yourself confused. So if my number cube has 1, 2, 3, 4, 5, and 6, how many 5s are in there? There is 1 out of how many? 1 out of 6. I just found my simple probability. That was it. For my second step, then I'm going to bring those 48 rolls back in. And I am going to multiply by the total times. So I would take my simple probability times 48. Make sure you wrap those 3 steps down and you write those steps to the problem next to it.
So because each problem has either sometimes I roll, sometimes I quit, that keyword is always open times.
Okay, so when I multiply 1, 6 times 48, what does it give me?
8.
It gives me 8. And my third step is just circle the answer. Because sometimes we write it down on our paper, but we don't circle the answer. Okay, make sure you have those 3 steps written down, and I'm going to click over to our classwork, and I'm going to explain it real quick because I'm having some people flip-flopping answers by mistake. I'm not signed in. How did I do that?